All right. Hello, everyone. My name is Rick Salsa. I'm a product manager here at NGINX and F5. And in this demo, I'm going to show you how to scale our Planet app globally using DNS with the F5 DNS Cloud Service. Now, before we get into the demo, I just wanted to take a moment to introduce you to this service. Our DNS Cloud Service is a globally available cloud agnostic managed DNS service that provides your DevOps teams with a fast, secure, cloud native way to make your apps and your microservices highly available. You can drop DNS cloud services into a CI/CD pipeline, or you can directly leverage our declarative API or ecosystem integrations like Ansible and Terraform. We also include for you DNS-based DDoS protection, and we provide redundancy at the DNS layer to help ensure your app's availability for your users. Now, today's demo is going to focus on using our DNS Load Balancer. The DNS Load Balancer provides an effective way to manage your workloads across your data centers or cloud providers. DNS Load Balancer really unlocks a straightforward, faster way to build in multi-cloud redundancy by providing your teams with geolocation-based traffic routing, intelligent DNS load balancing capabilities, and health monitoring to ensure that your users are always directed towards the most optimal instance of your application with just a few clicks. Now, as I'm sure you're all aware, application downtime is a big deal. An outage can impact your customer confidence and it can bring your business to a standstill. So the first step in our demo today is going to be to scale out the single instance of our Planet app into multiple regions within the US. So with NGINX Plus and the DNS Load Balancer acting together, traffic can automatically be directed around an impacted location when all of the servers go down within a particular region. Now, by steering your users away from a non-responsive instance, the DNS Load Balancer is using something called global server load balancing eliminates or helps to eliminate downtime by making sure that we're not sending your users to an application server or an instance of your app that is actually down. So to ensure that we don't send users to a location where all the backend servers are unavailable, we're going to take advantage of the local active health checks, which is exclusive to NGINX Plus. So DNS Load Balancer will send an advanced health monitoring probe to determine our app's health. And based on that response, it will then direct clients to the application instances in a region only if they are available. So even if your app has the world's best error page, why would you send your users to an instance that's experiencing an outage? So with that, let's actually go ahead and jump into the demo.
So while that loads up,
Yeah.
you mentioned that this health check is only available for NGINX Plus. Is there a way to hook in like your own health check with the open source version of NGINX or no?
Yes, absolutely. So we're taking advantage of what we call an advanced monitoring probe on the NGINX Plus instance. You on the DNS load balancing service can actually configure your own monitoring probes as well. So those monitoring probes can go to an open source instance of NGINX Plus, and you can set them up to look for actual specific on the content on the page as well. So the local health checking capabilities just gives us a little bit more detail in what's happening behind your NGINX Plus instance. And so with open source, we're basically relying on the content and the NGINX Plus instance at the front door that's going to give us the status on whether or not that particular instance is up. So what we're seeing here, everyone, is our DNS load balancer interface. And so the space application itself, I've gone ahead and set up ahead of time. And so what you can see here is we've got a single instance of a pool that's going to take traffic from anywhere and direct it to the one space app instance that we have running in the US right now. So this load balancing rule is where we define all of the details about our app. So you can see here, I've set it up for space, and it's going to return back what's known as a DNS A record. A DNS A record is basically taking space.nginx.org and giving us back a street address or an IP address. So that IP address is what the end user is going to be given from this proximity rule, and that's going to get them to the actual instance of our application. So here again, you can see it's users coming from anywhere. They're going to be directed to that US pool. So let's actually dig into the configuration and see what that looks like. So here I have my US pool, and you can see that that US pool is already set up with just that single instance. And we can see here, based on the active health check that we have going on, the instance is up and available. So right now we have that one instance, and we need to scale this out. We need to add some additional instances here so that if this single instance were to go down, we're not going to be sending users there. So the pool section is where you can add multiple members or additional NGINX Plus instances that are in other locations. This section here that I have for specifying the number of what we call IP endpoints returned is where you can specify how many answers to give for this particular query. So if I have multiple NGINX Plus instances, I can actually give back more than one IP address to the client. Now, let's spend a second talking about load balancing. So with DNS load balancing, we have several options. I've just set our particular pool up right now for round robin. And so what round robin does is essentially if there's multiple NGINX Plus instances within a pool, we're just going to randomly give back a response. Now you can use some other options like this ratio member option, which would allow you to do something like blue-green deployments. So if you were scaling up a new data center, you could use this particular algorithm to direct a certain amount of traffic from your original data center to the new data center. We also have an option which we call static persist. This is like a sticky session if you're familiar with sticky sessions with your HTTP ADCs. So it allows us to give a persistent answer to a user. So we're always sending them to the same NGINX instance. And then priority is another option which would allow us to do things like high availability with DNS. So we can use priority to give certain instances in our pool a higher value, and that's what we return. But say, for example, that primary region goes down, we have some other lower priority instances in a different region that we could then send out. And it's a great way to load balance multiple CDNs if you're using a multi-CDN strategy or even a multi-cloud strategy. You can have a preferred cloud provider take all of the requests, but if there's an issue with that cloud provider regionally, you can then fall back to that secondary provider. So there's a lot of flexibility that you actually have here in configuring how you want to, within a pool of NGINX Plus instances, send users to different locations. So let's actually go and add another instance to this US pool. So what I'm going to do is create what we call an IP endpoint. So this is anything that's available or accessible out onto the internet. So I'm going to add my pre-configured NGINX Plus that I have running in a different region within the US. And you can see here, I can specify a monitor and a port that that monitor should work on. So we'll save that. And now what we're going to do is we're going to go back into the pool. And there was another way I could have done this, but to kind of show you the different interfaces, we will jump around in some of the sections. But we're adding the second instance here to the Planet app. And by saving this configuration, we're now going to push that out. And now I've got two locations within the US that I can steer users to with our DNS load balancing record. So any users right now coming in will get one of the two instances, but if one instance, for example, were to have an issue, then it would fail and move on. So now let's go ahead and scale our app globally. So we're going to use DNS load balancing to do something we call geolocation-based traffic steering. So I'm going to set up some more NGINX Plus instances within the EU and within Asia so that we can take client requests coming in and making sure that we're sending them to the closest location or the closest NGINX instance that is available. And this is going to add resiliency to your deployment, but it's also going to improve performance and response times because users are not going to have to, for example, go from the EU all the way over to an instance in the US, but when they can actually be directed to a location nearby and get a more optimal response. So in this section of the demo, I'm going to actually do this through our API. So we have a declarative API, which essentially allows you to state what the DNS load balancing or traffic steering policies should look like. So it's a declarative-based configuration, which you can see here I've set up for the Space app. And everything revolves around that load balancing record. So here you can see we have our load balancing record for the Space app. And what's going to be a little bit different is in the proximity rules. So I alluded to it a little bit earlier, but proximity rules are how we actually determine where our user's coming from, and then determine where we're going to actually send that particular user. So you can see we've got a configuration here. If we look into the proximity rules, we can see that there is the Space app, that's our host name, so space.nginx.org. And in the proximity rules here, we've got our region. So we've got the EU region, and it's going to be sending traffic to a pool of instances that I have in this configuration for the EU. So scrolling a little bit further down, here's the actual configuration for that pool of European instances. And we're just going to keep things simple. We're just going to have one virtual server, and we're going to set a value of something called a TTL, or time to live of 30 seconds. So basically, this is a key to your client to say, hey, when you try to head to the Space app in Europe, that information is good for 30 seconds. Come back and check again in 30 seconds to make sure that that information hasn't changed, and we're always giving you an instance that's up and available. So here's the actual pool instances, or the virtual servers. So these are IP endpoints that we saw on the screen. You can see here I've got one now in Europe, and I've got two in the US. And so this is the declarative configuration, and then down at the bottom is the actual content. So I set up a region here for the EU. I'm just going to send this through the API right now, and we're going to get back, if you can see here, a 200 status code, which shows me that the request actually went through. And then the actual configuration, the running state of the service, comes back in the actual HTTP response body. So this matches the configuration that I just previously sent through the API. You can see there's a little bit of additional information there at the bottom, which is the name service. That's what we use to configure with our instance and wire everything up. So let's go back into the UI here, and we're just going to
I have a question here.
Sure. Yeah.
So if I have, is there a limit how many virtual servers or app instances I can have?
No, not at all. So there's no limits. You can actually have as many as you want, wherever you want. And that's one of the nice things about the service is there's a lot of flexibility in how you configure these pools and how many instances that you have within them. And then you can control how many answers that you give. So ideally, the idea behind here is that we're always sending the traffic to an instance that's always available. So as we have an auto scale, for example, in the actual service, the pools themselves can be changed and adjusted if that auto scaling functionality that you have built into your application goes and updates the pools. So to keep things simple for the demo, we have everything here with just one single instance in them, except for in the US.
Okay, thanks.
Yeah, no problem. So what we're seeing here is the EU pool. So this is just looking at it from the UI. So in the API, we declared this, we set this up, we created that single instance option here. So as I showed previously in the demo, we could click add member here. We could add more instances as we scale out. So if the application really starts to take off in that EU region, then we can essentially add more instances here. And we can add them in, again, a single individual region within multiple regions or across multiple cloud providers just for resiliency of the app. And then again, the DNS load balancing service is always going to make sure that it's actually sending traffic to an instance that's available. So if this instance in Europe was down here, we'd actually see that the member status would actually be different. So the time to live value is the important thing here. And again, going back to that, this is set for 30 seconds and it's set intentionally short so that the clients are constantly checking for the street address on how to get to the app instance. And we're always giving them or directing them to a client that is available. So we go back to the load balancing record where the policy for how we steer traffic to different locations is determined. We call these proximity rules. So right now, based on the API call, I've set up two particular rules. So the first rule here is for the EU region, and you can see that there's scores added to these values. The higher the score, the first match. So here we would match any user coming from the European Union, and we would direct them to that pool. And then the second rule you can see has a lower score, and it's kind of like a default fallback rule. So this is anybody coming from anywhere. Right now I've got it configured to give them an answer from our US pool. So one of the two NGINX Plus instances would respond to that. So how that would work is, let's say that the pool of NGINX instances had a availability issue. That rule, all of the members would be down, and that's where we would go into that fallback rule. So what I'm going to do to kind of round up the demo here is add a third region now. So what we're going to do is we're going to create a region for Asia, and we're going to add a member to that particular pool. So right now I only have my US and my European NGINX Plus instances. So what I'm going to do is I'm just going to go and add another instance here for my NGINX Plus version of the Space app running in Asia. So we'll add that to our pool. We'll select that from the drop-down list here, add it, and you can see that it's now an available member for this pool out of Asia. And we're just going to create that pool. And now that I've got that pool created, I'm going to go back into the load balancing record. Now, again, I could do that from this screen here as well by clicking the create pool option. But what I'm going to do before we create that rule is we're going to create a region for Asia. So this particular region is going to have users from Asia and Australia within it. And we're going to make sure that we're sending traffic to that pool in Asia. So we'll add that policy rule here. And now you can see we have two rules, both with the same score value. So again, we're going to look at that first, and then we're going to try to see, is the user coming from a location in the EU? Is the user coming from a region in the APAC region? And then we're going to direct traffic into an available NGINX Plus instance. But again, we always have that default fallback rule where if for example, if the Asia region was down, we're going to send users over to that default rule in the US. So let's actually go into a different tab here, and let's actually see what this all means now that we've walked through the configuration. So I'm going to use the VPN functionality in my browser to simulate my user or myself coming from different regions. So I'm going to turn it on for the Asia region first. And now what I'm going to do is I'm just going to refresh the browser screen, and I've updated the NGINX, the Space app just a tiny bit so that we can actually verify that we are indeed in a different or coming from a different region. So here you can see Space app is refreshed. I've updated the title to specify the region where this content is being served from. And you can see a little graphic that we have up in the top right corner as well, just again to verify that I am indeed getting a response from the Space app that's running in Asia. So we verified that. Let's actually go and make one more switch here. Let's actually try it from Europe. And obviously when we refresh it, we can see here that we've actually now are coming from that particular region. So as you can see here, quite easily using DNS, we can add resiliency to your application by just setting up a couple of regions and specifying a few pools with these policy rules to steer your users into a different location that they're actually looking for. So I just wanted to actually just finish things up with an ask for you. So if you're facing any of the challenges that I presented in this demo today, please take a moment and go to our preview page at f5.com/preview and actually register for our upcoming DNS Load Balancer and NGINX Plus integration preview. We're looking for customers and partners, we're looking for customers to partner up with us and give us valuable feedback as we look to kind of further our integration with the NGINX Plus real-time API. So using real-time data from an NGINX Plus instance, like your system load or the number of active requests or connections, we're looking to be able to make smarter, more intelligent traffic steering decisions. And we're trying to send your users not only to that closest NGINX instance, but we want to send your users to the NGINX instance that's closest, but is also going to give them the most optimal end user experience. So always remember, the closest instance isn't always the multiple one. There's many factors like system load that can impact the customer experience. So this integration is going to allow us to, again, deliver more valuable traffic steering decisions and making sure that users are getting the fastest response times from your app.
So I've got one question that seems to be on a lot of our minds. Like, where is the F5 DNS Cloud hosted? How resilient is that part? Because that seems like that's
You bet. Yes, very good question.
Link, right?
Yes. So the DNS Cloud Service runs on F5's global cloud services platform. So we use a technology called Anycast. Essentially what that means is our service actually runs in many regions, many different regions across the globe. And Anycast allows your user to always be directed to our closest and available DNS load balancing location. And the entire service is cloud native and resilient, so that if we do have an issue, for example, with our service regionally, we use pretty much the same technology. We're helping your app to move and make sure that it's always going to an instance that's going to be available and give up a response to users when they're trying to access your application.